Convert the following base 10 numerals to a numeral in the indicated bases. For part A, 173 in base 4. To convert a number from base 10 to another base, write the given number in terms of powers of the base, starting from the greatest power less than that number. To convert 173 from base 10 to base 4, the greatest power of 4 less than 173 is 4 to the third power. So let's take a look at that. Okay, so we know that 4 to the third power is 64. 4 to the fourth power is 256. So therefore, we can see that 4 to the third power is the greatest power of 4 less than 173. Thus, the place values are 4 to the third power, 4 to the second power, 4 to the first power, and 4 to the 0 power. And so there are 2 4 to the third powers and 173 with 45 remaining. So let's go ahead and take a look at that. So if we take 2 times 4 to the third power, that gives us 128. 173 minus 128 leaves us with 45 remaining. So now we have 45 that's remaining. So now how many 4 to the second power are in 45? So if we take 2 and multiply 4 to the second power, we get 32. 45 minus 32 gives us 13. So 13's remaining. So how many 4s to the power is in 13? Well, there's 3 of them, because 3 times 4 to the first power gives us 12. So 13 minus 12 gives us 1 that's remaining, and therefore we have 4 to the 0 power represents 1, so 1 times 1 and 1 with 0 remaining. So again, if we take a look at that, we know that 1 times 4 to the 0 power is equal to 1, so minus 1 gives us 0. So now we know what our numbers are going to be in the base of 4. So it follows that 173 is equal to 2 times 4 to the third power plus 2 times 4 to the second power plus 3 times 4 to the first power plus 1 times 4 to the 0 power. So here are your numbers, 2, 2, 3, 1. So therefore, we're going to write the numbers in front of the place values in the same order as they appear from left to right to convert to base 4. So 173 is equal to 2,231 in the base of 4. Okay, now we want to be able to convert 6,815 from base 10 to base 15. Now, the greatest power of 15 in 6,815 is 15 to the third power. So let's just verify that. So if we take 15, raise it to the third power, that gives us 3,375. We take 15 and raise it to the fourth power, that gives us 50,625. So therefore we need to use 15 to the third power. So the place values are 15 to the third power, 15 to the second power, 15 to the first power, and 15 to the 0 power. So there are 2 times 15 to the third power and 6,815 with 65 remaining. So let's go ahead and take a look at that. So if we have 2 times 15 to the third power, that gives us 6,750. And we're going to take 6,815 and then subtract 6,750, and that gives us 65 remaining. Now we got to figure out how many 15 to the second power is in 65. Well, there are 0, because 15 to the second power is larger than that 65. So 65 is still remaining, so we have 0 times 15 to the second power. Now how many 15s to the 1 power is in 65? Well, if we take 4, multiply it by 15 to the first power, that gives us 60. So 65 minus 60 leaves us with 5 remaining. And then since there's 5 remaining, we would say that there is 5 times 15 to the 0 power, which is equal to 5. So 5 minus 5 leaves us with 0. So it follows that we have 2 times 15 to the third power plus 0 times 15 to the second power plus 4 times 15 to the first power plus 5 times 15 to the 0 power. Now you want to write the numbers in front of the place values in the same order as they appear from left to right to convert to base 15. Therefore, 6,815 is equal to 2,045 with a base of 15. Now for part C, to convert 486 from base 10 to base 3, the greatest power of 3 in 486 is 3 to the 5th power. So let's go ahead and verify that. So if we take 3 and raise it to the 5th power, that's 243. If we raise 3 to the 6th power, then that gives us 729. So therefore, we have 3 to the 5th power, so the place values are 3 to the 5th power, 3 to the 4th power, 3 to the 3rd power, 3 to the 2nd power, 3 to the 1st power, and 3 to the 0 power. So how many 3 to the 5th powers are in 486? Well, if we take 2 and multiply by 3 to the 5th power, then we get 486. Well, 486 minus 486 leaves us with a remainder of 0. So therefore, all the numbers for the remaining place values are zeros, because the only way to get 0 as a sum of 3 to the 4th power, 3 to the 3rd power, 3 to the 2nd power, 3 to the 1st power, and 3 to the 0 power is by multiplying each by 0. So therefore, it will follow that we have 2 times 3 to the 5th power, 0 times 3 to the 4th power, 0 times 3 to the 3rd power, 0 times 3 to the 2nd power, 0 times 3 to the 1st power, and 0 times 3 to the 0 power. So 486 in the base 3 is 200,000 with a base of 3.